Hello, everybody. Let's do Somerset 5 solutions. This is arrays versus array lists. Problem 0, we already have the solutions because I made a type-along video for that one. So let's start with problem 1, creating random lists of numbers, first with an int array, second with an int array list, and then we're going to test them both from main. So I think I'll have side-by-side solutions, one for arrays and one for array lists so that you can contrast them more easily. Programming by intention, I will start with how I'm going to test it. So I want a method called makeArray that's going to output an int array. And int bracket bracket is the data type for int array. It takes two arguments. The first is the length of the array. The second is the maximum value of the random numbers that the array will get filled with, so 77. Rather than automatically create the method like this, I'm going to go ahead and type it because I'm just practicing. So I'm going to make a static method, static because I'm trying to run it from a static method. We'll talk more about static later. The return type is an int array. That's what I want it to output. It will be called makeArray, and the parameter list is a length and a max value. Okay, so if I want to create a new array, fill it with random numbers, and return it, the first thing I'll have to do is actually create the new array. I'm going to call it out for output. The way you create an array in Java is you give it the data type and a bracket, but then you have to define the length when you actually instantiate it. So the data type has bracket bracket with nothing inside, just to let us know that it's an int array. When you actually create the array, you tell it how long you want it to be. Okay, let's loop over the entire array up to length. We'll say output element I, and now I want a random number, which you've done this tons of times. And notice how I'm not really typing a lot. I'm just tab, 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 auto-completing. Okay, return out. So that's what that one looks like. Let's contrast that now on this side with what the same thing would look like if I wanted it to return an array list. So I'm going to start the same way. I'm going to have data type, variable name equals, and then my method. So the data type now, though, is going to be array list integer, because arrays can't hold primitive data types, and int is a primitive data type. Integer is the object version. It's the wrapper class for int. I'm going to call it out. It's called makeArray. Same thing, 10, 77. What am I doing? Oh. Okay, so public static array list integer makeArray int lang int max val. Okay, the side-by-side thing is really working. We'll look at them side by side in a second. Okay, so just like last time, I'm going to create an empty array list. I'm going to loop over it to fill it with values, and I'll return it. So to make the new array list, same thing. I have to start with the data type. I'll call it out just like I did last time. I have the keyword new to run a constructor. Array list. So a difference, though, is when I create the array list, I'm not creating it to be size lang. Array lists, you have to create them size 0 to start with. So this time, it wouldn't make any sense for me to loop up to like out.size, for example, because right now the size is 0. Instead, I'd want to loop up to a fixed value, which is how many elements I want to add. And I can't say out element whatever equals. I can't do this either, because out.getI returns a value, not a variable. And so I can't assign something to a value. I can only assign something to a variable, which can hold a value. So you don't use the equal sign. You say out.add. And what am I trying to add? Int math random times max value. Great. So that does the same thing. And now I can return out. There we are. All right, problem 1 done. And we are testing them. Let's display the results as requested. So I'm going to, in both cases, try and display just the variable. And it's going to work great with an array list, and you'll see it's not going to work great with an array. So let's do it with the array list first. So I made a length 10 list whose maximum value should be 77. Here's the list. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. And I don't see any values larger than 77. It's not the greatest test case, but it is at least a sense check to see it's not doing anything totally insane. On this side, let's run it. And here's what it printed, because that's the memory reference for the variable out. So in order to actually display the contents, I have to say arrays.toString out. Let's run it again. Okay, so now I'm getting something sensible, and that looks right. Okay, let's do problem 2. Method to sum up odd values. Write a method that takes an int array as input and returns the sum of all the odd values in the array. All right, let's do it in both sides. So I've made out, we're printing it. Do I want to call it sum? I didn't specify. Okay, so I'm going to call my variable sum. I'm also going to call the method sum. And the method just takes an int array as output. So public static. This time I'm going to output an int because it's the sum of all the values in the array. So that the sum is just a single int. It's called sum. And the parameter is an array because I'm trying to give it an array. And so I need a new variable here called array that will hold an int array. All right, I want to sum everything up. So I'm going to create a variable called sum that starts at 0. I'm going to loop up to array.length. And in this case, it would be a mistake for me to say 10 here because, yeah, the way I'm running it right now, out is length 10, and so I'm going to sum up something length 10. But if I hardcode 10 here, and then I change this to be 13 or something, now all of a sudden my whole code is broken. So each method needs to stand completely by itself and work independent of any other method. So if I'm accepting an array, you need to ask the array how long it is, rather than assume based on how you happen to be using this method for this particular program. Okay, so I'm looping up to the end of the array. I'm going to say sum plus equals array element I. Remember, plus equals is the same as sum equals sum plus array element I, like this. So now I'm adding each next element into the sum one at a time. And by the time I'm done, I should have added up all the elements. And so I'll return sum. Okay, let's make this, well, that's fine. We'll just keep it the way it is. Let's do the other side. Well, let's run it. So s out sum, and we'll run it, and then we'll do the other side. Okay, 407. If I weren't very, very confident that this was working, I would hand check this with a calculator. If it seems too onerous to hand check it with a calculator, you could make this shorter and then hand check it with a calculator. Let's do the other side. Okay. So, same thing. Int sum. I'm going to take out, here's an input. It's a static method. I'm returning an int. It's called sum. The parameter should be an array list of integer. I'm going to call it list. Here. Same thing. I'm going to have a sum variable that starts at 0. I'm going to loop up to the end of the list, only this time on the left I did on the left I did array.length. Here I'm doing list.size. That's one of the main contrasts that you're going to be practicing. Sum plus equals list.getI. So on the left, with an array, you have the bracket way to access elements. Here we have the .get method. And then at the end, I'll return sum. And then let's run it on this side to make sure it works. Okay. Oh, I didn't print it. And we're printing it. Okay, looks good. Representing a deck of cards. Yes, I remember the student who wanted to make a deck of cards. So we're going to use values 2 through 10 for the number value cards. And then, that doesn't make any sense. Oh, it does make sense. 10 is a card. I don't play cards a lot. So then 11 is Jack, 12 is Queen, 13 King, 14 Ace. And a lot of people pointed out Ace can also take on the value of 1. And that's true, but for representation purposes, we're just going to choose to represent it as 14. And then in the actual game itself, you could choose to count the number 14 as being a value of 1 or a value of 14, depending on the context. Okay, so let's represent it as an array list of integer. We want 4 of every value, so yeah, let's do it. So I'll do this one on the array list side. I'm actually going to encapsulate it in a method. Integer deck equals make deck. So I know this is not what the problem asked, but I like to do things inside methods. And make deck is not going to take any inputs at all because I want it to be a full deck. Okay, so in the problem we already have creating the deck variable. And then we're going to return it. And so now I'm going to do a couple of loops, and we'll fill it with values. So I think probably the most straightforward thing is let's loop through each value we want first. And I like to name my loop variable for what it represents when it actually represents something. So this is like the card value. So card values are going to go starting at 2 and go all the way up to and including 14. And then for each value, we're going to add it 4 times to the deck. So, well, here, let's do it one step at a time. So here's all the values. Here's deck.add val. Whoops. And let's just print out what we've got so far. So here, I'm going to comment all this stuff out. You can select a region and hit Control-Shift/ to comment the region. So let's print the deck. And right now I should just have numbers 2 through 14, as you see here. Let's add 4 of them. So here, instead of doing a single one, I could just do this. I could just add each one 4 times, and that's perfectly fine. Now you can see them. Instead, I could write a loop. Oops. That loops 4 times, where I'm going to add the value 4 times. So the outer loop takes on each value, and then in the inner loop, for every single value, I do that exactly 4 times, and so you'll see this returns the same thing. There it is. You see 4 2s, 4 3s, 4 4s, and so on. I think what I'll do right before I return it is collections.shuffle deck. And so that will randomize the order of the elements in my array list, because I don't want to return the deck all in order. Even though that is, when you buy a deck of cards, I think they come all in order. Okay, so it's a little bit harder to verify now that I have exactly 4 of each, but I've already done that before I shuffled it. Okay, cool. So I think that's working. Testing a list. Problem 4. Given an array of ints called nums, return true if the array contains no 2s and also no 5s. In other words, if the array contains a 2 or a 5, we should return false. So it doesn't contain 2 or 5. Okay. I got it, Mr. D. Okay, Okay, I'm going to name my Boolean variable no 2 or 5. The method is called doesn't contain 2 or 5. What a terrible method name. Okay, I'm going to give it out here to test it. Okay, everything else looks good. So how am I going to test if it contains no 2s or no 5s? Let me think about what students do. Hold on, I'm going to pause it. Okay, so here's a logically straightforward way to do this, which is not going to be the most direct way of doing it, but we'll do it two ways. So if I want to confirm that this list doesn't have any 2s and it doesn't have any 5s, here's what I could do. I could say number of 2s equals 0, number of 5s equals 0. So I'll have 2 counters. And then I'm going to loop through the array, and I'll say if array I equals 2, then I'll increment the number of 2s. And if the array contains a 5, then I'll increment the number of 5s. So now I've got, at the end of looping over the array, I'll have counted how many 2s and how many 5s, and then I'll say if the number of 5s is 0 and also the number of 2s equals 0, then I'll return true. Otherwise, I'll return false. And that should work. There's a shorter way of doing it. If I'm looping over the array and I get to a number 2, there's no sense in me checking any other values in the array because I already know that I'm going to return false. If I'm checking to see if there aren't any 2s and 5s, and if I find a 2 or a 5, now all of a sudden I can just exit right away. So let's do that version. In that version, I'll start with the loop up to array.length, and then I'll say if array element I equals 2, I'll just immediately return false. Or let's do this, 2 or array element I equals 5. So if it sees either one of those, I'll return false. And are you ready for the error? Here's the error. So putting an else statement here, I think a lot of students are used to logical conditions where, like, if we see it, we'll return one thing, and if we don't, we'll return the other thing. Here we are exiting too soon. So think about looping over a list that looks like this. Let's say the list looks like 6, 10, 3, 4. Okay, 6, 10, 4. So the first element, we ask, is it 2? The answer is no. We ask, is it 5? The answer is no. So we go to the else condition, and it would just return true right away to say the list doesn't contain a 2 or a 5. But we don't know because we've only looked at the first element. So, in fact, if the list had had a 5 at the end of it, we would have exited with true already before we even had a chance to find the 5 at the end. So when you're searching for a thing, when you're searching for a failure condition, as we say, or you're searching for an exit condition, if you don't see the exit condition, you have to keep going until you get to the very end of all the things you're going to check. So if we see the exit condition, then we can exit right away. Otherwise, we keep looping until we get to the end. So this would actually be my preferred solution. The other one also works fine. Let's do this. So right now I'm testing it on the random output here. But that's maybe not a very good test case because, let's take out the... Sorry, let's run this side. Okay, here we go. So for one thing, I'm not printing out the output, but for another thing, because my max value is 77, it's very unlikely I'm going to display 2s or 5s. Let's make my max value be 7, and let's make it be... Let's do this, actually. So I'm trying to think about what's a good way to test this. So let's loop like 10 times, and then inside the loop, all right, so I'm making some lists, I'm printing them, and I'm saying, do they not contain a 2 or a 5? And we're doing it over and over again so that we can see lots of test cases. Right now, they're all false because every single one of these, let's just make sure. So this one's got a 5, this one's got a 2, this one's got a 5, this one's got a 2. So let's make my max value something like 20. And now hopefully we'll get a better mix. Okay, so this one's got a 2, so it's false. This one doesn't have a 2 or a 5, so it's true. This one has a 2 and a 5, so it's false. This one here has no 2 and no 5, so it's true. So notice what I did. I went ahead and put my test case in a loop with a whole bunch of random test cases. But I had to think carefully about ensuring I was going to get both positive and negative test cases. So when you're actually testing real code, this was kind of a toy method. So I will forgive you if you didn't want to test it thoroughly. But if you have code that you actually care about working, you probably do want to test it thoroughly. I made random test cases. You might want to hand create a bunch of test cases so that you're sure you're covering all of the potential inputs that you might have to face. Okay, let's do it on the other side. Are we supposed to do it on the other side? The answer is yes. Same method for array list. Oh, I actually do say to test them on 4 specific. All right. Should read my own problems. Let's do this. All right, so I'm going to comment out the making of the deck. And then over here, I'm just going to delete the sum. Over here, I'll do S out. I think I called it doesn't contain 2 or 5. And I take that as an input. All right, so public static, it takes in ArrayList integer as input. It's called doesn't contain 2 or 5. Oh, no, sorry. The output is a Boolean because I'm returning true or false. It's called doesn't contain 2 or 5. The parameter list is just one variable called ArrayList integer. I'm going to call it list because that's my conventional, typical name for an array list. So same idea, let's loop over all the things. If we ever see a 2 or a 5, let's return false. So here I loop to list.5. I will say if list.get I equals 2 or list.get I equals 5, then I'll return false. Otherwise, at the end, I will return true. Let me float an idea with you. So list.getI happens twice here. Students tend to just put this as many times as they need to. Consider this. What if I did it once and assigned it to a variable called value? I don't know in this case if you think this reads more easily than the other one. But certainly in other examples, rather than just repeat .get over and over again every single time you need a value, it will definitely read more cleanly to store it into a well-named variable and then use that variable over and over again. So I just wanted to float the idea with you that this is possible. In this case, you can decide, but in other cases, this will definitely be the right thing to do. Let's now manually construct some test cases. So rather than pass it out, we'll do this. So array list integer. So test case 1 is going to be new array list, but then I can actually create an array list with values by saying, is it list dot? No, it's arrays dot as list. Yeah. So let's create a list that has no 2s and no 5s. Okay, here we go. So now test case 1 is this list, 6, 10, 8, 3. And now I'll copy and paste those 2, 2, 3, 4. So now I'll have 4 test cases. And I can do one that's got a 2 in it at the very end. I can do one that's got a 5 at the very beginning. I can do one that's got a 2 and a 5. So now I'm constructing some different test cases. Where I'll print out test 1, and then test 2, and then test 3, and then test 4 like this. Now let's run it. Comment that out. Okay. Okay, so true, false, 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 and that's what it should display because the last 3 test cases all contain a 2 or a 5, so it is false that they don't contain a 2 or 5. My purpose here was just to show you what it looks like to create some proper test cases. In Java, there's a code framework. There's actually several different frameworks you could use for what's called unit testing, where you can set up test cases and the correct answers, and it will run through them and tell you how many of your test cases you passed, how many ran correctly with the right output, and how many you failed. But we're not going to do that. And then on this side, you could do the same thing, only instead of saying new array list, arrays as list, it's much easier to create an array with some fixed values in it. Let me just show you what it looks like very briefly. So here I could say int bracket bracket test1, and then here I could just say, 6, 2, 4, 10. Except, of course, that's not how you do it. You use curly braces. Okay, like this. All right, so this is how you would do a similar thing on the left-hand side, and you could do it 4 times. Let's move right along. We are now on more practice of objects. So we're going to create a sphere class. It should have a constructor that takes a radius. We should have a get and a set radius. We should have volume. We should have toString. Okay, let's do it. So I'm going to close this one. Sphere class, huh? So do I already have a sphere class in my project? I do not. Great. So Java class sphere. That was asking me if I wanted to track this file with Git, and I do not. Okay, so let's do the attributes. What attributes does a sphere need? Well, a sphere should have a radius, and maybe that's all. Yeah, maybe that's all. So let's just do that. I'll auto-create the constructor by hitting Shift twice, constructor. There we go. I will auto-create getters and setters by hitting Shift and typing getter setter, and then I'll click here, and there's my getter and setter. Cool, so that much is done. It needs a volume. Here is a common mistake. So some beginning students think that if I'm going to volume, some students think that if I need to have a method called getVolume like this, then I have to have an attribute called volume, which then I would set here in the constructor. And you could do this, but let me tell you what the danger here is. This.volume equals, and then we'll say, well, let's have it just be full of errors. Okay, so 4/3 times math.pi times the radius cubed. Okay, so this contains this contains like 3 mistakes. So one mistake is this is not how you cube things. So if I'm going to cube something, you could say math.pow, but it will execute much faster if I just multiply radius by itself 3 times, which is what cubing is when it's a positive integer, when the exponent is a positive integer. This 4/3 is not actually calculating 4/3. This calculates as 1 because I'm performing integer division because 4 and 3 are both integers. So 4 divided by 3 is 1 with some remainder, but the remainder doesn't actually calculate. It'll just truncate to 1. So probably making one of these two things be 3.0 fixes that problem. Okay, so now at least I'm calculating the volume correctly, but here's the danger. The danger is I calculate the volume exactly once when I first create the sphere. And then later on, if I set the radius to be something different and then I get the volume hasn't updated. The volume is still what it was with the old radius before I updated the radius. So this would not be a good solution to this problem. If you really wanted to, you could do this. In set radius, you could recalculate the volume. And so that's fixed it. I'm not thrilled with this solution. We don't really have a strong need to store the volume as an attribute. One reason you might choose to do this is if it takes a lot of time to calculate the volume, then you might just want to calculate it whenever the volume changes and not recalculate it. But doing this calculation is computationally cheap. It does not take a lot of time to do the calculation. So I actually want to leave out volume entirely. And we're just going to calculate the volume whenever we need it based on the radius. So I'm going to paste in that computation. And so now we don't store the volume. It's just that whenever anyone wants to know, we repeat this computation. And that would be very wasteful if this took a long time, but it doesn't take a long time. So that's the solution I'm going to choose to implement. What else do we need to do? Oh, toString. Right, the toString should return something like your circle has radius, whatever. Okay, let's do it. So here, I'll do public string toString return your circle has radius, and then plus radius. Ta-da. And so now I'm sure that I am asking myself to test it. Let's see what I actually say. Make a tester class, run the spheres constructor, run all the instance methods to make sure that they work. Great. So let's do that. Here I'll say sphere s equals new sphere. We'll give it a radius 5. Let's print sphere so we can see. Let's print the volume, s.volume. Now let's do set the radius to something else. Let's double the radius. And now let's print the sphere again to make sure it updated. And then we'll print the new volume. So this is me using all the methods to ensure they're working. We'll run it. Radius 5, and there's a volume. Radius 10, the volume has clearly changed. If I was very uncertain about my computation, I could double check those with a calculator, which I am not going to do. All right, are we getting close to the end? This feels like a longer problem set. 6, 7, okay, 2 more. So 7, random list of spheres. Let's make a method that creates and returns an array list to hold spheres. Great. So it's called make spheres, size of the array list, and it's going to return a list of spheres. Okay. Again, programming by intention, I'm going to imagine I already have this method, and I'm going to use it to create an array list of spheres. So make spheres is the name of the method, and I'm going to make 10 spheres. Let's import array list, and now let's make spheres. Here we are. So the return type is an array list of sphere, because that's what I want it to output. It's going to save into this variable. And then I'm not going to call the input I, I'm going to call it length. So similarly to making a list of random numbers, I want to start by creating the array list that I want to output. Call it output. New array list. It's empty when I create it. Now I'm going to loop for the number of times, for the number of spheres I want to create. And then I'm going to make a sphere. New sphere. I need a random radius. What does it say? Random radii between 1 and 200. So notice that that's not a parameter here. So I'm going to calculate int math.random times 200, but this is 0 to 199, and so now I'm going to add 1 in there, so now it'll be 1 to 200. So I create a random number that's the input to the sphere constructor. So now I've got a random sphere, and then I've got to add it to my array list, output.add s. So I've really broken this into some separate steps. And if I really wanted to break it into 3 separate steps, I could do this. Rand radius. And then here we got random radius. Okay, so I make an empty list. I want to repeat for the number of spheres I want to create. I make a random radius. I use that radius to run the sphere constructor once I have my sphere added to the list. So you can really do them kind of in separate steps. A lot of programmers would say we should just combine all 3 of these lines into a single line. I would say, yeah, sometimes. For debugging, it's actually easier if you do one thing per line, because if something goes wrong, I can set a breakpoint and check each value separately more easily. But we'll talk about that later. At the end, let's return output. And let's just make sure that this is doing something sensible. Let's output my whole sphere list. Let's just make it list length 3 so that I don't overwhelm my buffer here. So here's 3 radii. Here's 3 spheres. Your circle has radius 132. Your circle has 188. Your circle has 70. So in a list setting, our toString method maybe doesn't make that much sense. So I'm going to change my toString method to just have the radius, and I'm going to run it again. Okay, so that's maybe a more sensible output in a list of spheres. Okay, I think we're done with that. Random list of spheres. Great. Cool. 7, a method with lists of objects, right? A method that takes an array list of sphere objects as input and returns a new list consisting of all the spheres that are larger than the last one in the list. Okay. Get large spheres from. Okay. Here we go. So I'm making some spheres. I'm going to output an array list of sphere. Large spheres. Get large spheres from, I think is what I called it. And I'm getting them from the sphere list. All right, so let's make this method. So this method, the return type is an array list of sphere, because I'm outputting a new one. That's just going to be the large spheres. The input is also an array list of spheres, because that's the list I'm going to be looping over. As we did before, let's make a new array list that will hold my output spheres. Whoa. All right, so let's loop over each sphere in the sphere list. Well, I'm going to loop over the indices. We don't know about for each loops yet. This would be a great time to use a for each loop. All right, so I'm looping through the indices of the sphere list, and now I want to, you know what I'm going to do? Well, so here's what you could do. This is less my favorite. So you could say sphere list.get element I, and then now that's going to be a sphere, and now I'm going to check that one's volume. And I'm going to say if the volume is greater than, oh, how do I get the last sphere in the list? Well, I guess I've got to say sphere list.get, but then here I have to give it the index for the last element. So the last element is, let's see, sphere list.size -1. And then I want to check the volume of that. Okay, cool. So this now expresses the idea that I want, but it's kind of terrible to read. Wait, what do I want to do? Well, yeah, let's do that part. So here I have found that the current sphere, its volume is larger than the volume of the last sphere in the list. So that's everything I've checked. So in that case, I want to add that particular sphere to the output, because it's one that I want to remember as being a large sphere. And then here at the end, I'll return output. Okay, so this works, but this doesn't roll off the tongue, so to speak. You can't just look at it and say, aha, that's, obvious at a glance what I am doing. You have to think about it, for a little beat. It's not complicated. It's not hard to think about, but you do have to pause for a beat to take in what's going on there. So let's do this. Here would be my preferred solution. I'm going to make a sphere here called next sphere. That will be sphere list.getI. And so now I can make this say next sphere and this say next sphere. So already this looks a little bit better. If the next sphere's volume is greater than this thing, then add the next sphere to the output. Okay, but let's improve this thing. So I could also say sphere last sphere list.get sphere list.size -1. All right. And so now I can say last.getVolume. So this reads a little bit better if the next sphere's volume is greater than the last sphere's volume. There's something that's a little bit wasteful. It's not that wasteful, but it seems weird to me to get the last sphere out with every single iteration. So I would probably do that here outside the loop. So I have a list already when I'm past it, and I say, okay, let's grab the last sphere in the list. Now let's loop through all the rest of them, and for each of the rest of them, we'll get each one at a time, and then we'll do the check we want. This, again, would have been a great spot for a for each loop, and then we could make it look even simpler. But that's probably okay for now. Okay, I think we're done. So let's do this. Let's make this be length 8. We'll print out the sphere list, and then here we'll print out the large sphere list, and we'll see who is larger than the last one. Okay, so here the last one is radius 82, and here we've skipped 58, we've kept 103, we've skipped 8, we've kept 176, we've skipped 9, we've skipped 50, but we've kept 125. So that really seems like it's working. Great. And that was the end of that problem and the end of the problem set. Cool. I hope that this was helpful. If you have any follow-up questions, I'm always happy to answer them. Come back next time. Thank you so much.